Good evening, ma'am. I'm Vishnuvardhan of Aerobee section. Today I'm here to explain about TikTok. My topic is tools for multiple CPU environments. So first we'll see the introduction. The most effective approach to gaining significant increases in computing power over the next decade appears to be through the use of multiple CPU environments. Such environments let you break up a problem into concurrent processes that will often run in a fraction of a time required by a single CPU environments. Possible arrangements for such a multiple CPU environment cover a spectrum from parallel computing, where the environment as a single computer with multiple CPUs, to distributed computing, where the environment has several loosely connected single CPU machines. Unfortunately, to take full advantage of this capability, you must ensure that the code is optimally partitioned into processes. So once you have done this, you must map the processes onto processes. If you do the partitioning or mapping poorly, you might actually get a net slowdown or incorrect behavior. To best use the power of multiple processes, we must make the jobs of process identification, process partitioning, and processor mapping easier for programmers to write new programs. Likewise, because performance analysis, testing, and debugging all possesses unique aspects in a multiple CPU environment, we must pay special attention to these problems. So, this is section describes 5 tools that address these problems. The first set of tools has been PPSC, and Integral supports this activity by providing specification or design languages for concurrent applications. The next pair of tools and Total supports the development of multiple CPU software by representing the software's behavior in a parallel or concurrent environment. So we concern ourselves only with making it easier for programmers to write new programs for multiple CPU environments. We will fail to capture the full benefit of multiple CPUs. A huge inventory of software exists whose performance could be improved considerably by migrating it to a multiple CPU environment. In fact, it is this base of existing application that has prevented more organizations from taking advantage of multiple CPU environments. Thus, we must also attack the problem of making it easier for programmers to repartition and remap existing code for multiple CPU environments. So, the descriptions in this section clearly do not form an exhaustive list of tools for multiple CPU environments. However, they do represent the approaches being taken to address the problem of multiple CPU computing today. This section describes 5 tools aimed at the problem of serial to parallel conversions. The first set of tools, ESP, Mimdizer, and Preds, captures the design of the original source code and displays it in graphical form for analysis. The remaining tool supports direct source to source transformations. Tools for multiple CPU environments, software and its engineering, software creation and management, software verification and validation, software defect analysis, software testing and debugging. So these are the 5 tools for multiple CPU environment used in software. So thank you, ma'am. Thank you for giving this opportunity. If there are any disturbance, sorry for the disturbance, ma'am.